Great. Thank you, everybody. I'm Julie Hurd. I'm Director of Technical Marketing for E8 Storage. So thanks for having us here today. I'm going to go into a product overview, high level on what we do and how we do it. Then we're going into other sections, and Zavon will do a deep dive on the architecture in a little while. So why is E8 Storage different from all the other all flash arrays? You know, we didn't want to go out and say, I'm the next best. I'm another all flash array, but what's different about us? Well, we're an architecture built specifically for NVMe. And I'll hit NVMe in a second for those who aren't already living and breathing NVMe SSDs. So because we were designed for NVMe, we get near line rate access or near line rate performance out of our system and out of the SSDs inside. We do scale in multiple dimensions. We can scale out the hosts. We can scale up the capacity. We also have very simple centralized management. Because we're built on NVMe, built for SSDs, we don't have a lot of complex tuning that's required because it's really fast storage. And then high reliability and availability. Those are pretty much check marks you have to have in today's market. So let's step back into what is NVMe. Fundamentally, it's a communication protocol. The NAND underneath is the exact same NAND you're going to find in a SATA SSD or a SAS SSD. It's all 3D NAND, and it's the same NAND that goes in regardless of what front-end communication protocol is put into the SSD. What makes NVMe different, though, and why you can actually unlock all the performance of the NAND underneath is that stack. It was designed for flash. There's no legacy spinning media considerations in the protocol, which means you don't have to worry about that head thrashing. So you have more command queues, because a regular HDD can only have one command going in at a time. That head can only be in one space at one time. And that's where SAS and SATA have to make sure that they're serialized so that that head is only in one space at one time. It's a physical constraint. SSDs, though, are flash. You can send electronic messages across all the paths inside the NAND, which means you have more commands, more queues. So SSDs, rather than having one command queue that has one command going in at a time in serial, the SSDs can connect up to 128, depending on the device. Anywhere between 80 and 128 connections into the SSD in parallel. Which is why we can connect so many hosts having direct access to each of the SSDs. Each of those queues is much bigger as well, exponentially larger. So now we've got up to 64,000 commands per queue for NVMe. Again, this is because it takes full advantage of the capabilities of NAND. Nothing about having to worry about any of the spinning media limitations. So that is fundamentally why, if you take just a SAS and an NVMe SSD, you'll see just the performance comparison between the two, simply because of the protocol is optimized for flash. Okay. So beyond just NVMe, when NVMe first came out, it's built for PCIe, which is also a very low latency bus inside of a server, which is where you're seeing the most of the adoption for NVMe happening up front. PCIe does not natively expand. So getting outside the box and actually getting to scalability requires a different transport protocol. And that's where NVMe over Fabric comes into play. It provides the command sets that you can take NVMe, the protocol itself, the communication protocol, end to end from your host to your target, regardless of what medium is in between. So there's several different NVMe over Fabric protocols that are emerging, depending on what kind of transport medium you want to use. We use RDMA over Converged Ethernet, or RoCE. There's also iWarp, and also InfiniBand. These all use remote data memory access, which is a feature I'll talk about in a moment. There's also some non-RDMA protocols coming out, so folks that want to continue their investment in Fibre Channel. So there's a RDMA or NVMe over Fibre Channel, also TCP. Those folks that are
Is that people who want to preserve their investment in Fibre Channel, or Fibre Channel vendors who want to preserve their business?
It's a fair question. Given that it's the Fibre Channel vendors who are proposing the protocol, you would have to generously assume that they're doing it because their customers want it. So we'll be generous.
Julie, you are more generous than I.
So that's NVMe, and a very one-slide condensed, 15 or 20 slide deck condensed into one for what is NVMe and why it's really the underpinnings of what we do. But why Ethernet? You just talked about Fibre Channel. Why wouldn't we use Fibre Channel? Because everyone in storage does Fibre Channel. Well, Fibre Channel is still out there, of course, and it's still the primary protocol for Fibre Channel SANs. However, Ethernet is ubiquitous. And you can see from the market data High-speed Ethernet actually has already surpassed Fibre Channel in terms of installed ports, and it's growing a lot faster. Fibre Channel is actually on the decline. So Ethernet, largely because Ethernet's not only ubiquitous, it's also less expensive, and it's easier.
Less expensive because it's ubiquitous.
Exactly. So and these are the numbers are the dollar per port. That's just me Googling, taking a couple of switches that I found on Google and doing a direct comparison of what you can actually purchase now on the open market. So 100 gig E is $800 a port. The 32 gig Fibre Channel is $2,000 a port. So now it's costing me 4 times more, 3 times more, whatever that number happens to be, for a third of the performance, as far as a third of the throughput.
And even more when you realize that 100 gig port can be 4 25 gig ports.
Exactly, because yeah, you can do port splitting, which is what we do in our architecture, because the hosts themselves can't push 100 gigabit Ethernet, but you still want to use a 100 gigabit Ethernet backbone, because we can certainly push all 4 of our 100 gig ports. So yeah, the port splitting, it's ubiquitous, it's part of the Ethernet protocol, and that's what you can really do in the Fibre Channel SAN. And Fibre Channel SAN does want everything to be like speeds end to end. And it's easier. It's easily routable. Everyone knows Ethernet. And actually, thanks to the ne'er-do-well FCOE, the features that Ethernet needed to actually support storage in a lossless manner have already been implemented, and they're actually standardized in all the switches coming out 10 gig and above.
I'm going to push back a little on routable.
Okay.
NVMe over TCP is routable. Rocky isn't.
So,
This was a statement about Ethernet as a general statement of Ethernet.
yes. Rocky v2 is Rocky encapsulated over UDP and IP, and it is routable. Although you're right that it's a kind of new protocol and not as ubiquitous as Rocky v1.
And the concept of routing NVMe is offensive.
Well, I agree with that, just because every time you would hop, it adds latency. And the whole point of going to an NVMe high performance system is to get lowest latency.
Right.
So no, from that perspective, absolutely, I agree with you on that one. Okay, lost my train of thought. I was about to say something that went completely off sideways.
I hate when that happens.
Good job, Howard.
And then just reliable. I mean, it's a well-vetted standard. It's been around for several decades. So not really worried about it being stable or not stable. Everyone knows you can just plug into Ethernet. You know, there's no plug fest anymore for Ethernet because it just works. So when we say we architected for high performance NVMe, we didn't just add NVMe into a standard dual controller architecture, because now you've got bottlenecks. We came up with a new architecture in order to get rid of those bottlenecks. Fundamental to that is actually, well, we have centralized control, but distributed data. Centralized control means that we can still do the high availability. We have a dual controller appliance that gives us failover capabilities. It manages a lot of metadata, so that when we start doing things like shared LUNs, we still have that central metadata server that controls who gets access and when. So we still have that control. It gives us the availability and the reliability. But now we distribute the data path, because that's where the vast majority of your work is happening, is in the data path. That's where we do have that E8 host agent. That's right, I have a pointer in my hand. We have the E8 host agent that installs on every server that's going to access storage. Those host agents offload roughly about 90% of the data path operations off from the controller, which means that every time you add a host, you're also adding compute power for not only your compute clusters, but also for your storage. So that gives us more scalability.
The client, is that how much in terms of overhead?
The cost of the client in terms of overhead.
Yeah, because you're offloading that overhead to the client. So
we usually would, depending on how many clients we have, it's usually a core. We'll take one of the cores for the E8.
SPDK, right?
Say again?
You're leveraging SPDK, Intel?
Yes. You are literally the Intel developer kit. So yeah, we do take a core for the E8 host agent. Right now, when we see the performance figures later, those are 16 hosts, 16 agents and 16 hosts, usually about what we're going to see being able to push enough data across the line to max out the line rate. So 16 cores for us is right that sweet spot of being able to actually get all of the performance that's available out of the drives. Because we have 24 drives inside, so it takes a lot of I/O to actually max out those drives.
and from an agent perspective, platform support is...
From the agent perspective, we support Linux. So we do support several flavors of Linux. Red Hat Linux, of course, being one of the most popular, but also Debian, Ubuntu, and CentOS.
Any specific kernel requirements, minimum?
We support as far back as
6.5 was the oldest.
6.5 is the oldest. We're up to 7.4 now.
Yep.
So 6.5 to 7.4. Okay. All right. And then one of the things we do leverage is the performance of the remote data memory access. And this is actually where you get the really, really fast reads. Because we use RDMA, we do leverage it from the NIC. So any RDMA-enabled NIC on the host as well as our side can leverage, is what we use to get this feature. So that when the A8 agent wants to read, it can actually bypass the CPU and memory of the controller and go straight to the drives and read that data. So the control path obviously is where is the data, but reading the data and bringing it back out goes straight through the NIC up through the data path. So that's where we really get the best performance and take out a lot of latency. So not going through the CPU, not going through memory, takes out more hops. Very low latency rates. So you can see when we look at the side-by-side performance, and these are FIO results. So end-to-end testing from the host to our box, not within the box, as we've seen some of the folks that are doing. But if you can do a comparison, and these are some published figures, so an all-flash array, which I won't mention who they are, but we'll just say in AFA, on your left side of each of these graphs for the IOPS, the throughput, and the latency. You can see they're not remotely getting the throughput and the IOPS you can possibly get out of a drive. And if you compare that in the center with a single NVMe drive, a single NVMe drive can outperform a legacy all-flash array with 24 drives inside.
AFA on the left that's doing 300K is actually is it one that's also advertising they use NVMe?
No, this would be a SAS.
Oh, that's a SAS.
Yeah, yes, this would be SAS numbers, not one of the newer ones that have NVMe inside.
What are you seeing from them? Are they any better? I mean, how much?
They are slightly better, but again, they're hitting their bottleneck is in the controller. So in many cases, the vendors are actually maxing out the number of drives maxing out the controller before they max out the drives.
Can I ask you what a legacy all-flash array is?
Anything that is prior to last year. So any of the dual controller architectures that have been around for a while, that were originally architected around the idea of spinning media.
Obsolescence just comes faster and faster.
So, and then compare that on the right-hand side to an E8D24, and these are our published figures. So you can see we are getting up to 10 million IOPS. So we're getting almost all the IOPS capacity out of these drives, 40 gigabytes per second throughput, all in, as well as roughly on average 120 milliseconds of latency. And depending on, of course, that's workload dependent. And your mileage may vary, always applies. So it's not just about performance, because customers need options, and they need deployment options. So we have a couple of different ways that customers can scale. So first of all, they can scale the hosts, because we're not looking for the folks that are okay with a single server. Those folks really are good enough, are okay with a good enough array. They probably maybe not even have made the transition off of hard drives yet. Those aren't our customers. Our customers are the ones that really need very high performance and very low latency. They're the ones that are making their money off of their server, their storage architecture that says, okay, this is what's driving my financial transactions. This is what's driving my online bookings. This is what's driving genomic sequencing. Whatever that high performance, low latency application happens to be, they're making their money off it. So they need a lot of servers. They'll be running single servers in serial or parallel clusters, parallel databases, or parallel file systems. So each of those we can scale up to 96. And actually that's really dependent on the drive. Because I talked about earlier, NVMe can then have anywhere between 80 and 128. We averaged it out, we published 96. But it depends on which drive vendor we have inside as to how many hosts can connect.
I think you mean reduced processing time, no?
The increased processing time? Oh, I should say reduced, you're right. Increased performance, increasing performance or reducing processing time.
It makes things slower.
Yes, it was right when I was translating the slides and updating them.
Blame the Israelis.
It was all my fault.
So you write them in the original Klingon and then translate?
Anyways, so yes, it does. Actually, we've seen in customers it reduces the overall time because they've gone from a unclustered database system to cluster. And by doing that, they're able to actually do parallel processing, a 4x improvement in the overall performance.
Now, you said there was differences between the NVMe vendors. Mm-hmm. Can I ask who wins in this race? Or what? And who are we dealing with? Intel, Samsung,
So we work with all the major drive vendors. I couldn't tell you off the top of my head who does what. I'd have to actually go back and ask my hardware engineer to remind me who does which
Those-
queues.
These ones, yeah.
And then she would say it on live video and annoy people.
And then I would never say it on live video anyways. See, that was the, I don't have the data and now you're calling me on, no, I would not do that.
Even if I had the data, I ain't giving it to you.
No. Well, Intel, Samsung, Western Digital, I mean, those are our top 3 partners. They're all great partners and they all have strengths. It's just a difference in the media itself.
Oh.
So, okay, so also, in addition to scaling out the hosts, we also want to scale out capacity. And not only this is the ability to connect right now up to 4 appliances per E8 host agent. That's a testing limitation, not an architectural limitation, because a half a petabyte of block data is a whole lot of block data. So we stopped at 4, but it's not an architectural limitation. This also gives us the ability, connecting to more than one host, to actually have more than one drive type in the back end. So we could have any appliance or 2 that are just NAND flash. Then also add in Optane. So we've been doing a partnership with Intel on the Intel Optane, and we'll talk about the use cases in the next segment for the Intel Optane. So that gives us the ability to have both types of drives for those customers who need like absolutely superior performance out of the entire system.
Always nice selling to the cost as no object customer.
Hey, if there were more of those, we'd all be happy.
Mm-hmm.
Well, Andy would be happy. He'd be very happy.
That's because Andy works on commission.
Yes. So start small and grow. We also know that customers don't necessarily always know upfront how much storage they need or how fast their databases are going to grow. So being able to connect to multiple appliances means they can right-size the appliance for what they need upfront at today's prices, and then add more, because it really is just plugging into the Ethernet. You're not disrupting a major architecture. You're adding another plug into the port, which with Ethernet is actually quite easy to do.
What would be the logic about adding more appliances to a single cluster? Because as you add an additional shelf or shelf of disks, that's another component that could fail. You've now got 2 shelves, and if you wouldn't spread across 2 shelves, would you, for example, because now you've got 2 shelves, one of which could fail, or both could fail, so you've increased the risk
So
of not working in that scenario.
the reason you would do it, though, is if your database was outgrowing your existing capacity. So if they are one of the folks that, like most folks, don't actually get rid of any old data,
Yeah,
and eventually their database is going to outgrow what they can do.
which is fine, but you could just put in another appliance and move somebody. And
Well, that's the point. You can actually put in another
yeah,
appliance.
but why classify it as being like a cluster of appliances? Isn't it just a number of appliances that happen to be on a network?
In this case, I'm not talking about a cluster. I'm just actually talking about adding in more
okay,
appliances.
So that's the key bit I was trying
Right.
to get to, I guess.
Okay.
That's not a cluster in that sense. It's
In this sense, no, we're not
just
talking about a
more-
cluster at
it's
the
more
moment.
shelves in a rack rather than.
So that is one of the items we're going to be talking about in the architecture. You can have them as just federated. All of
Right.
them are serving up data, or
Oh,
we can
for
look on,
management.
or
Yeah.
we are working on having them clustered as well in case a customer wants that.
Right, okay.
Chris, you realize you were just asking why scale out?
Well, but if you do a scenario like that where you spread across two devices, you've now got either one that could fail. So unless you've got redundancy across them, you've increased your risk. So why would you do that?
Yeah,
No
but-
logic to doing it.
Well,
But a clustering would make a lot of sense, obviously. That's a different scenario.
yeah, it's just
Okay. Okay.
Shut up now. I was right again. I'll shut up.
Hey, I'll go with it. All right, so simple centralized management. So our management GUI is actually pretty intuitive. We're going to go over that in the demo section in the next section. But so it is a web-based design, accessed by the network, so you can actually access it remotely from anywhere. In this case, the system that we're accessing, I believe, is in Tel Aviv, and we're doing a remote demo of that. So that's the benefit of having a web-based design without having not needing a dedicated server. All of the host and volume management happens from the GUI, and we'll go over that and how that works. One of the joys of the E8 agent is that all these volumes that are provisioned to hosts are auto-discovered. So on the host side, once we provision storage to those servers, it just shows up as a block device. Then you mount it, do whatever you want with it after that.
I assume you're managing all the agents from this GUI as well as the array itself.
I'm sorry, say again?
You're managing the agents from this GUI as well as the array itself.
Once they're installed, yes.
Is there any? Do you have to install them manually? There's no deployment mechanism.
Currently, we still have to install them. Yeah, we don't have a centralized deployment of agents onto the servers. So, because part of the server setup is also updating your drivers for things like your NIC and your network. And so it's actually the networking portion that takes the majority of the time. So.
And are there APIs that can be leveraged for this that the customers could use, or?
So we do have a RESTful API. Actually, yes, I do have a RESTful API. We also have the CLI. So the RESTful API, yeah, if you want to be able to do an API-based management. Also, if you want to do centralized monitoring, so we do have SNMP, so we can capture the MIB and get those traps to a centralized monitoring tool. So we understand that we are actually integrating into somebody's environment, not going into a clean environment where they don't have anything else but us. So we want to play nicely with what they've already got. Of course, health monitoring, callback, all the standard features that customers want for supportability and reliability. Power protection, thermal shutdown, of course. All again, this is a company or a set of a company and a set of people that have been a long history in enterprise storage. So we know at least the minimum check marks you got to have. So.
Can you roll back your operating system if you want?
Let me ask one of the engineers. They don't actually let me play on the system very often, so.
Just ask. You brought up upgrades on that last page, so I'm just asking.
Yeah. As far as the non-disruptive upgrades, yes. Yeah, you can actually roll back.
Thank you.
Yes. Sorry.
That's so hard. Others have problems with this.
Others earlier this week.
Okay, availability and reliability. So one of the keys in the architecture that we've actually built into the architecture is reliability and availability. On the software side, each of those host agents are independent entities from each other. Of course, it's got the centralized communication back to the controller, but if any one of those agents goes down, it doesn't have any impact on the rest of the agents and the rest of the servers. So that server goes down for whatever reason, that data, of course, stops, but all the access from all the other hosts keeps going. And of course, everything is now protected, RAID 6 protected on the controller, so the data is fine. Once the host comes back up, it can reconnect to its LUN, and it's good to go. So that's keeping the entire system alive, even if one portion of the components fails.
Okay.
Yeah.
NVMe over Fabrics being somewhat infantile is kind of lacking in multipathing. Are you guys addressing that?
We do have multipathing capabilities. Our implementation is actually a superset of NVMe over Fabric. So, because some of the features that we have are definitely not built into the NVMe over Fabric protocol. So I could not actually claim.
Yet there,
Huh?
We can hope
Yet.
that there's a yet.
Correct, yet.
Well,
So-
that's not up to you. That's up to the committee.
Yeah, so things like our RAID, how we do replication, how we do shared volumes and LUNs, those are proprietary to us. So again, we are a superset of NVMe over Fabric. We're not just NVMe over F. So,
Okay.
yeah.
And what are the current plans for allowing NVMe over F access? Because somebody believes agents are too evil to install on their servers.
That would be a NDA level discussion that we won't be talking about here.
Okay.
All right. And then
Got a pen.
I gave you a pen. Yeah, you have a pen, be happy, and spinners. Come on, man. Last slide for me. Sorry.
Lost the train of thought.
I lost my train of thought. Howard has that effect on
That's
me.
what happens when you
Thanks,
pay
good job.
attention to me.
Is that license to ignore you?
Oh,
Yeah,
at your peril.
yeah, absolutely.
Quite a lot of nodding heads around the room.
So on the hardware side, we actually have a couple of options depending on what the customer wants for availability. So our standard offering is our D24 or X24 if it's got Optane inside, which is the dual controller appliance with no single point of failure on the hardware, and that's what we have here in the room. We also have a single controller version, which is actually what we came to market with originally last year. If the customer is doing software-based replication, that single controller appliance is actually more fit for what their needs are because they don't need the HA in the controller. They've already got replication functionality built into their applications. So it's an alternate implementation that we have for those customers that need it or want it, actually. So. All right. And that concludes my section.